Class. This is going to be our video for section 3.2, which is titled Compound Statements and Connectives. So the purpose or general overall view of this section, this is sort of like in chapter 2 when we did our set operations, intersection, union, and complement. Those were like the operations for the set theory. And so what we're talking about in 3.2 today, these connectives, those are the equivalent of our operations. And so we're going to go through some and or, just like we did with set theory. But then we also have some if-thens, which are new and specific to this logic and truth table stuff. So, but that's our overview of what we're doing today, is we're kind of getting to our operational aspect of our logic and truth tables. Okay, so as always, if you want to follow along in Blackboard, I am using the same handouts as we had last time. Let me bring those up in case you didn't have them from 3.1. All right, so I'll be starting with the chapter 3 key definitions, ideas and definitions and key ideas, and then when we get to examples, we'll be looking at this lecture examples for 3.2. There. So let's get into the document camera and get going. Let's start with compound statements and connectives. So a compound statement is, just like a compound inequality had two inequalities. Well, compound statement has two or more statements. You're going to love the or more when you get to the second half of the 3.3 homework. Those problems are getting kind of long, like longer order of operation problems. For this, a large part of 3.2 will stick with just a couple of statements, but we'll start getting into some longer ones as well. And so the connectives, those are the equivalent of the operations that we talked about in chapter 2. So our connectives there's 4 of them. There's and connective, an or connective, an if then, and then the fourth one is if and only if. Now you might think of negation, but negation technically is not a connective because negation only requires a single statement to negate, whereas all connectives are working with 2 statements or 2 or more at a time. All right, let's just walk through these. After we describe all of them, go through the symbology, then we will get into some examples of all of them. All right. So the first one is our and statement, our and connective. So remember we're dealing with P and Q and R and S as our statements. And so if we have P and Q that is symbolized by P and sort of an up arrow Q. Does that remind you of anything? Hopefully that reminds you of the intersection symbol, only it's an arrow instead of like a U shape. But this is, and is basically the equivalent of intersection. But in logic, in truth tables, it's called the conjunction. I really need to get a highlighter for this. All right, so for and statements, it's an up arrow. Okay, and so it works just like you think it means. So if we're connecting 2 statements, I like peanut butter and chocolate, you have to be careful. This and is not a connective in logic because it has to be 2 statements. I like butter pecan, that is a statement, but chocolate is not a statement. So even though there's an and, doesn't mean we have a conjunction. Right? So you'd have to say, I like peanut butter and I like chocolate. Then you would have 2 statements, and then that would be a connective. But the and statement is called the conjunction. Sometimes we use but, yet, or nevertheless. So when we're translating from English over to symbols, watch out for those words. And I really don't, to explain fully what we're doing with these connectives, We need to get into true tables, which is 3.3. So the purpose of 3.2 is mainly just so we know what the connectives are and how to translate them from math to English. That's the we're not actually using them. We're just setting up the problems right now. The first connective is and. Okay. Second connective we have is or. Or is basically like our union. And so when you do P or Q, the symbol is now a downward arrow. Right? I don't know about you, but again, it looks like a little bit of a little U. So now we have a downward arrow V, however you want to think about it. That is P or Q. And so an or statement officially is called a disjunction. So and is conjunction, or is disjunction. Okay. Now we've talked about or before with union. One thing you have to be careful of is when we're dealing with or, we're dealing with an inclusive or, which means P or Q or both. Right? So often in English, when we say or, we mean one or the other, but not both. But we're in math. So in math, we need that inclusive or. So or will be both. And once we get to the true tables in 3.3, you'll see where that comes into play. All right. So the third connective we have for two statements is called an if-then statement. Right? And so if P then Q is symbolized, and now we have an arrow going to the right. And order is very important with if-then statements. If you have an if-then, it's called a conditional statement. And then, it's conditional. We don't have, to have Q depends on whether or not we have P to start with. So conditional statement is the official name of an if-then connective. Right. And we definitely read, just like a grade 10 lesson, we read them from left to right. Okay. Connected or conditionals or if-thens do not go both ways. Just because, if we have, if we say if P then Q, we can't assume if Q then P. Right. So the arrow is pointing to the right for a reason. Something else you might see just language-wise, I'm not really going to use these words much, but you may see them. The first statement, the one on the left, which we're labeling as P, that's called the antecedent. And then the second statement on the right is called the consequent. Again, those are just fancy terms for our starting statement and our ending statement. Something that's going to get mentioned here and there, which since we're stopping at 3.3, we're not going to have to deal with this a lot, but just another language of logic that you need to be aware of is something gets mentioned a fair amount. Sufficient versus necessary. So I think the best way to explain this, if something is necessary to happen, if P is necessary for Q, that means Q cannot happen unless P happens. All right. So that has to happen. The first condition has to happen for the second condition to exist. So that's a very strong, I guess, requirement. A weaker requirement or a weaker condition is sufficient. If we say P is sufficient for Q, that means if P happens, then Q will happen, but Q can happen without P. I think a good example of this, if I say, if you're taking this class, then you're a Carl Albert student. So if you're taking this class, that is sufficient for me to say, yes, you're a Carl Albert student. However, there are a lot of Carl Albert students who are not taking this class. Okay, so it's not necessary to be a to take this class if you're a Carl Albert student. It is sufficient to say that you are a Carl Albert student, but you don't have to take this class. That's the difference between sufficient and necessary. Necessary can't happen without the initial condition, without the antecedent. For sufficient, the consequent can happen outside of the first term happening. Again, that's not something we're going to mention a lot, but it does pop up occasionally. Translating, something to watch out for. All right, which that kind of goes into more detail, what I was just saying. Um, and often, like the necessary part, if you do try to flip it around, like if I say, if you're taking this course, you're call algebra student, it's efficient for you to be a Carl Albert student if you're taking this course. But if you flip it the other way, if you're a Carl Albert student, that is necessary for you to take this class. You can't take this class unless you're a Carl Albert student. So that's kind of the necessary part. It often happens if you flip an if then. And definitely don't fall into the trap of that if thens go both ways. Like I said, order is extremely important. So if we say if P then Q, that does not mean it's a big no that you can't say that Q, if Q then P. All right. The conditional, the if then is a one-way arrow for a reason. Only go in that direction. And you'll see this as we start translating. There are a lot of English equivalents for if then. This is where we kind of talk about 3.1. They can be a little bit confusing or misleading. So you have to be careful with those. And I've been doing this for a while and I still make mistakes sometimes with this. So we'll see this as we go through the notes. All right, so that's our third. So we have the conjunction, which is an and statement, the disjunction, which is an or statement. We have the conditional, which is an if then, and then our fourth one is an if and only if. Okay. So P, if and only if, is symbolized. Now we have a arrow going both directions. Write that a little bit bigger. You can see it. So this is called a biconditional. Bi meaning two. So if we're going both ways on the if then, so we have both conditions. It's often abbreviated IFF, for if and only if. Okay. So like I said, the biggest difference between conditional versus biconditional is it is going both ways. So a biconditional tells us if P then Q, as well as if Q then P. And this is, if you hear the phrase necessary and sufficient, that's when we get into the biconditionals. A regular conditional is just sufficient. A biconditional is necessary and sufficient. Okay, so those are our four what we call connectives. You can also think of these as operations. And so, like I said, the operating part we're going to say for 3.3, but let's get into some translations. All right, so what we're going to do now is we're going to translate English sentences into conditionals or connectives. Basically, going to write them in symbols. As we're doing this, don't forget about the negation of P, the tilde P. That's not a connective, but it is part of the translation. Okay, so let's just work through these problems, see what it looks like. All right, so given that P and Q represent a simple statement, write the indicated compound statement in its symbolic form. Okay, so anytime we're talking compound statements, that means we have a connective. And or if then or if and only if. And the way they set this up, this is good practice. If you're ever translating English to symbols and they don't tell you what the statements are, then that's sort of like a word problem, like figuring out what's important. Like saying P is this and Q in this really helps the operation. Okay. So P, Tosca is an opera. Q, Carmen is an opera. Right. So let's so we need to translate this into symbolic form, into symbols. So Tosca is an opera and Carmen is an opera. All right. So since we're dealing with two or more statements, what separates the two statements? That's where I start with these. Okay. And this is where I really wish I had a highlighter. So Tosca is an opera and Carmen is an opera. So we know we're dealing with an and. So an and is what symbol? The upward arrow. Okay. And again, order matters. So on the left, Tosca is an opera. Well, what is Tosca as an opera? That is P. And then on the right, Carmen is an opera. harmonious octave is Q. So that is just P and Q. That's all they're looking for. That's what they mean by putting it in symbolic form. And when in doubt, you know, have your, you might want to make a flashcard with have this on smaller stuff, and is that, or is that, if then is that, so that's a good reference term, but you could probably even make it a little bit more condensed. All right, so how about number 3? Spartacus is a film, Rambo is a film. Yeah. Yeah, so that Spartacus is P, Rambo's film is Q. So we have Spartacus is a film and Rambo is not a film. So the connection between those two sentences is the and. We know we're dealing with the up arrow. On the left-hand side, now it doesn't have to be P first and Q second. So make sure that you're getting the order right. So on the left is Spartacus is a film. So Spartacus is a film is P. On the right, after the and, Rambo is not a film. Well, Q is Rambo is a film. So what is Rambo not a film? Well, that not, don't forget, it goes back to our negations. Yeah, so that tilde. So if we saying this is not a film, that would be not Q. So P and not Q. All right. So let's just keep working through these. It just takes practice. All right. So P is she drives at 80 miles an hour. Q is she gets a speeding ticket. So she drives at 80 miles an hour or she gets a speeding ticket. So again, step 1, identify the connection. Step 1, identify the connection. Okay, so we're dealing with or. So what's the symbol for or? Symbol for or is the down arrow. Yep. So now on the left, so the first thing is she drives at 80 miles an hour. Okay, so she drives at 80 miles an hour, that's P. And I wish they would vary this up a little bit and put like Q on one side, P on the second, but yeah, I think I get the idea. She drives at 80 miles an hour, or she gets a speeding ticket. She gets a speeding ticket is Q. Now, with the and the or, the order, we could say, like if you look back up at 3, we could say not Q and P, or on 4, we could say Q or P. So, as long as that not has to go with Q, as for and ors, you can get away with the order because it doesn't really matter in the long run. The if thens absolutely matters on the order. So it's a good idea to just always go in order. Okay. All right, that just avoids some later confusion. All right, 5. P, this is a brontosaurus. Q, this is a dinosaur. Our statement is if this is a brontosaurus, then it is a dinosaur. So what's the connective? Well, we have an if then. If then means an arrow to the right. Now it absolutely matters what's on the left and what's on the right. And so the left is the first half of the sentence, the right is the second half. Okay, so this is a brontosaurus is P. This is a dinosaur is Q. All right. So let's go ahead and see how much you can do with 6 and 7. And this is where in class, I really wish I could just kind of let you work on your own and see if you have questions, but it doesn't work in this case. So. All right. So 6, we have an if then. If then means an arrow to the right. So on the left, this is not a brontosaurus. So it is a brontosaurus. So not a brontosaurus means tilde P or not P. And then on the second one, this is not a dinosaur, but Q is a dinosaur. We want not a dinosaur to be not Q. So that would be not P if if not P, then not Q. That's how we read them. What about 7? P is cone has 3 scoops. Q is a cost of $1.85. And cone has 3 scoops if and only if the cone cost $1.85. So if and only if, that's our biconditional. So that is kind of hard to read there, but that's an arrow going both ways. So we need arrow to the left and to the right. All right. So again, since it's going both directions, you can technically put them on either side, but again, let's just practice keeping everything in order. On the left side, has 3 scoops. That is P. Cost $1.85. That is Q. So that's P if and only if Q. Yes, these are kind of basic, but again, we're learning a new language, so we're trying to start slow, and we're going to warm up to messier problems. Okay. All right. So before we do more examples, let's go back to the definitions. And talk about quick picture what we're doing. And so what we've done now is we've just did a very basic translation from an English statement to symbols. And so now we're going to get more in depth. But let's talk about some big picture stuff before we jump into the messier problems. Okay. So remember we're connecting sentences, not single nouns and verbs. So be careful if you see an and, make sure that like on each side of the and, it's a whole sentence, not just a single word. Something I highly recommend is that when you see a sentence, write out what P is and what Q is. That makes it so much more straightforward, I think. What else? Parentheses matter. Okay. And so remember, we said connectives are between 2 or more sentences. So as we get into that or more part, we're going to get, we're going to have, if we had 3 sentences, we'd need 2 connectives with them. If we had 5 sentences, we'd need at least 4 connectives between them. So as we get more and more statements, we need more and more connectives. And again, just, parentheses are like grouping symbols, in this logic part. So that kind of works like order of operations. So parentheses are grouping symbols. Think of it that way. What that means is that, typically if we start with symbols, we're going to give you the parentheses. But if we're starting with English statements and you're putting them into symbols, you need to figure out where the parentheses go. Okay. So now technically, you don't have to have parentheses because it's like if you put something in the calculator, you don't always have to put every single parentheses because the calculator knows order of operations. But if you don't know order of operations, it's really helpful to have those parentheses. So this is the same idea. At this point, unless you've done this before, you're not used to order of operations, so you really need those parentheses if you're having work that one connected. Yeah. Down the road, if you feel like you're reading this really well, you might be able to do without them, but it's better to have parentheses and not need them than the other way around. Okay, so with one thing we talked about order of operations, it's the order of operations is there because it tells us what's important, and so what do we do first, what do we do second, and so on. Now, in logic, for whatever reason, they call this order as the dominance of the connectives, which sounds like a weird term to me too. And one thing I will point out is when you're reading in the book or in the MATLAB examples, for whatever reason, they tend to go from least to most dominant, which to me is backwards because in normal operations, we start with what's the highest priority and work down to the least. That's why we start with grouping symbols and then go to exponents and end up with subtract. For whatever reason, this topic is normally done in reverse order. They start with the least important and go backwards. So just be aware of that in the book. And like what I'm telling you now may look backwards from the book because I'm going from most important to least important, whereas the book goes from least to most. All right. So when you're looking at your connectives, by far the strongest one or the most important or the most dominant is the biconditional. That means if you have two symbols, and you know, you have like a biconditional and an biconditional. If there's no parentheses, the biconditional is important. So it's really kind of like, think of this. If you see a biconditional, you can think of it as like a parentheses before the biconditional and parentheses after. And so if you have a second connective, it's going to be inside one of those parentheses. So after a biconditional, the next kind of the lowest down, a little bit lower from that is the conditional. So since we no longer go both ways, this is slightly less important if we're only can guarantee it in one direction. So after our biconditional conditional, the third most important is the conjunction and disjunction are our ands and our ors. And if you have both of them, this is sort of where we go back from reading left to right. And remember, we're getting these from sentences a lot of times, so we're reading our sentences from left to right. So, but conjunction and disjunction are equally important. It's sort of like multiplication and division. You don't always multiply first and then divide second. It's do whichever one's on the left first. That's the same with ands and ors, with conjunctions and disjunctions. All right. And then the lowest priority or the lowest dominance is the negation. And large part of that is because negation is not a connective. It's not connecting two statements. Negation is on a single statement. Unless you put parentheses, outside the negation, sort of like with, so if you have, something like this, you are negating both of them, but that's because you got to do inside parentheses first. If there's no parentheses with a negation, then you're only negating what it's immediately next to. All right, so that's the order. Highest priority is biconditional, then conditional. Then the third lowest is our ands and ors, and the least important in terms of work operations is negation. The other thing I will say, other than just be aware that the book and MATLAB both will list them. When they list them, they're going to put negation at the top, make it sound the most important, but then they'll say it's from least to most dominant. So just remember that I think the book is backwards on how they write it out. The other thing is, since we're translating this from English often to symbols, pay attention to commas. Okay. What do I mean by that? So let's look here. So we have if P, then parentheses Q and R. So if you read that, that would be if P, comma, then Q and R. So that means that you're gonna, what do you do first? Because of the parentheses, you're gonna find Q and R first, and then you're gonna apply the if-then statement. So that's sort of like one thing, and then your if-then is the important connective here. That's the secondary one. That's kind of what we'll do first and get it out of the way. Okay. However, if we put parentheses around the if-then, so if P then Q, parentheses, and R, this is read if P then Q, comma, and R. Well, what this means is you apply the if-then first, because it's inside parentheses, then you apply or deal with the and. Okay. So, as always, deal inside parentheses first. But if there's no parentheses because we're starting with English, then we're going to have to figure out where to put the parentheses based on this. And so talking about the commas, if you look at these two statements, where's the comma? So on the first one, it's after the P. So if P, pause, then Q and R. All right, so that's saying that, the if is sort of the important part, then the Q and R is kind of together. Whereas on the next one, when we have the parentheses around the if then, so if P then Q, comma, so that's before the comma, so that's all one thing. And then like here, you have the Q and R is after the comma. So that's, pay attention to commas as we're going through the English translations. Okay. There's a lot of ways to word these, so it's hard to say, do it, look for this one specific thing every single time. So we just need to get in there and do some examples. Okay, so I'm back into the 3.2. stuff. And so let me see. All right, so I'm gonna start at number 8. So given that P and Q each represents a simple statement, write the indicated symbolic statement in words. Okay, so we're starting with symbols and going to sentences. This is always going to be multiple choice in math. All right, so P is Emilio dislikes Laura. Q is Laura dislikes Emilio. So what we're dealing with is the negation of P and Q. All right, so how do we translate this? Start inside the parentheses. Okay, so inside the parentheses, we have P and Q. So what does that mean? That Emilio dislikes Laura and Laura dislikes Emilio. Okay, so they dislike each other. Okay. And then we're going to negate that. So what's the negation of they dislike each other? Well, they don't like each other. No, don't dislike each other. Okay, so let's see if we can find the one that works. Okay. So it is not true. Okay. Well, I like that already because that might be the negation that Emilio dislikes Laura and Laura dislikes Emilio. I kind of like this one to start with. I'm going to read the rest of them, but this is our negation. It's not true that, well, Emilio dislikes Laura, that's P, and Laura dislikes Emilio, that's Q. So that one looks good already. Okay, so Emilio does not dislike Laura, so does not dislike. So that sounds like that's a negation of Emilio. That's not P. But what symbol is but? We haven't talked about that. Remember but and, so that's our and connective. Laura dislikes Emilio. That is Q. So I could write that without parentheses, so it's not B. It would be parentheses. Emilio dislikes Laura, but Laura does not dislike Emilio. So if Emilio dislikes Laura, that is P. And no, but remember, but is the same as and. Laura does not dislike Emilio. Well, Q is she does, so she does not, it's not Q. So this is, good, notice that I'm writing the symbols, even though I think I found the right one. This is a good way to practice this. What about D? Emilio dislikes Laura, and Laura dislikes Emilio. So it was right. The first one, it is found. And so the way I got that is not true. That's a good opening statement for a negation outside of parentheses. Okay, so now we have the same P and Q, but now we have no parentheses. So if we have no parentheses, okay, so basically what we're saying is and is a higher priority than the negation. So we're doing the and first. So we're gonna the only one that's negated is Amelia. So let's go through this. Amelia and Laura do not dislike each other. Well, that's for both. It can't be that one. Amelia does not dislike Laura. Well, that's our not P. Or Laura dislikes Amelia. It's an or, that's an and. So or is the downward arrow, so it can't be B. See, Amelia does not dislike Laura. Does not dislike, so that's our not P. But, and this is where you have to be careful because remember and, let me pull it back here right quick. So and the other words we use for and are but, yet, and nevertheless. So this, these are words that you need to get familiar with. It looks like in these examples, but it's coming up a lot. So remember that. So but or dislikes Emilio. So there we go. And then it is not true. Well, that goes back to what we get on number 8. All right. So again, it doesn't ask you to write the symbols for everyone, but as you're going through that, it's helping you learn to read these. Okay. All right, what about the next one? Roger dislikes Zoe. Zoe dislikes Roger. All right. A lot of dislike in these examples. Could be more positive. All right. So now we're doing not P and not Q. So what's the higher priority? It's the and. So that means we're anding not P and not Q. So both of them are getting in. So Roger and Zoe do not dislike each other. So both of those are getting in do not. So there we go. Now I could go through these three again, but this is, I remember now I copied this problem, and when I copy a problem, it doesn't change it a whole lot. So these three statements are going to be ones where I talked about two other times. So sometimes you get more comfortable with this. You don't have to go through every single one. But let's do a different set. All right. Oh, now we have three. So now we have, this is the or more part of the connective. So P, the car's been repaired. Q, the kids are home. R, we will visit Aunt Tilly. So we have the parentheses here, which helps. So P and parentheses Q. So if Q, then R. So that is P and if Q, then R. And so we're taking those symbols and writing them out in English, that being and that being if then. That could also help. All right. So we're not negating anything. So we know we want the car to be prepared. We know we want the kids to be home, and we know we're going to visit Aunt Tony. Let's go through this. The car has been repaired. So that is P. And the kids are home. So that is Q. Keep trying to want to make that an A instead of just a number. So the car's been repaired and the kids are home. So we will visit Aunt Tilly. So what is that so? Well, that so is an if-then statement. So what's happening here is the car's been repaired and the kids are home. So the parentheses around the P or Q. Then, so if that, then we will visit Aunt Tilly. So that is one of those mini phrases for if then. So we will. If the car has been repaired, okay, so as soon as I see this, I know I'm going to have a right arrow. So if the car has been repaired, so that is P, we will visit Aunt Tilly. This sounds like a double arrow here, or an arrow going two if thens. So if the car has been repaired, we will visit Aunt Tilly if the kids are home. So when I see this, to visit Aunt Tilly, what has to happen to visit Aunt Tilly? The car has to be repaired and the kids are home. The car's been repaired and the kids are home. So this, to me, this seems just like number. This seems like A. So if the car's been repaired. Sometimes even they throw me off a little bit. Let me try this again. So if the car's been repaired, we will visit Aunt Tilly. Oh, so to me, let me come up here. So if the car's been repaired, we will visit the Aunt Tilly if the kids are home. So to me, I'm sorry to give the shine there. So this is two if-then statements. We don't want two if-then statements. All right. So it's definitely not B. All right, see, the car's been repaired, and we will visit Antilles if the kids are home. This one's looking good. So the car's been repaired, and so that's P and so anytime you have an so we will visit Antilles if the kids are home. So if the kids are home is R. If the kids are home, then Q. No, sorry. If the kids are home is Q, and then Antilles. So the car's been repaired is P, and we will visit Antilles just R if the kids are home. So if the kids are home goes first. So that's the antecedent. And then the consequent is we will visit. So this is where you have to be careful, because even though Antilles in the sentence was listed first, the if part is actually what goes before the arrow. So the if part is the kids are home. So that's if Q, then R. So that is the answer. All right, so so what that shows is that with if then statements, you have to be careful translating from English to math. All right, because often in English, we're going to put the result before the if then statement. That's not uncommon. We don't have to, but it can easily be that way. Now, if this if then statement had been at the beginning of the sentence, then we would have probably said if the kids are home, then we'll visit Antilles. But since it's sort of in the middle of the sentence, then a lot of times it gets flipped around. Okay. Now, again, sometimes even if you're having a little if, like what if this is right or not, look for stuff that doesn't work. It's multiple choice. So like for D, there's an or. There is no or in this statement. So right off the bat, that means it can't be D. Right? And then when I look at B, there's two if statements. There's no two if statements here. So right off the bat, just by recognizing that, that tells me it has to be A or D. Okay, and so then you have to be a little bit more careful. But here it's there's two things, the and, so that's where your parentheses is. It's kind of hard to explain this stuff sometimes. It's just you got to get a feel for the flow. All right. Let's see if I can make a little bit less of a mess of this one. All right, so Q and R, PQ. So we have three statements again. P is there's a blizzard outside. Q is we do not have to go to school. And R is we're going sledding. All right. So first place parentheses as needed. Right? And then we're going to translate it. Okay. So not R. So if not R, then not P and not Q. So what is the highest priority? Where are the parentheses? Okay. So what is the highest priority? Is a biconditional. Do we have a biconditional? We do not have a double arrow. No. Do we have a conditional? Do we have an if then? Yes. And so what that means is everything before the arrow is in parentheses, everything after the arrow is in parentheses. That is how we use the dominus of the order of operations. Okay. So if not R, what is R? I like this. They go, so not R is we don't go sledding. So what I'm going to do is let's go through and cross out anything that doesn't have this. So if we do not go sledding, so it might be A. If we go sledding, so it can't be B because we're not sledding because it's not R. The go sledding, again, can't be C because we're not sledding. Okay, so just by that, we've narrowed it down to a 50-50 shot. Good. Okay, so P is there is a blizzard. We want not P, so we say not a blizzard. Then there's not a blizzard, not a blizzard. So that doesn't help us because both of them have not a blizzard. Okay. And, or, okay. So we want an or. Well, there's an or, there's an or, so that doesn't help. And then not Q. Q is we do not have to go to school. So not Q is we do go to school. So we have to go to school, have to go to school. These are everything. If we do not go sledding, if we do not go sledding, then there's not a blizzard outside, then there's not a blizzard outside, or we have to go to school. Okay, so hopefully this doesn't happen in math lab. If you notice, A and B are exactly the same. So there shouldn't be two right answers. So what probably was meant to happen, I'm going to guess that was supposed to be an and. Okay, so I'm fixing the problem on the fly. Okay, so um, but they both, not a blizzard, not a blizzard. So they both have not P. Q is don't go to school, not Q is do go to school. So do go to school, do go to school. And so if this one's or and this one's and, which one is the correct one? Well, now you gotta know that's an or. We don't want the and, we want the or. So when you get to complicated symbol formology, a lot of times it's easier to think of each piece rather than try to like translate the whole thing at once. All right. You know how this got kind of complicated because we were trying to have to do the whole thing at once. Um, like I reverted back to more basics here, um just the more complicated it gets, the harder it is to have a big picture. Much easier, I think, to look at smaller parts of the picture. All right, so hopefully that helped. Okay, how about this one? All right, now again, this is a little bit hard to read. That's supposed to be R and an arrow both ways, P and Q. So first thing they want us to do is put parentheses. So we have an if and only this, and we have an and, which one is more important? Biconditionals are the most important. So what that means is parentheses have to go before and after everything to the left has to have parentheses, everything to the right needs to be inside of parentheses. Okay, so um, so we need an if and only if. Okay, if and only if. So if you notice, B has an if there is, so there is no if and only if. Okay. And I'm going to bring you that IFF. And if you look at D, if we go sledding, so there is no if. Okay. So just by that, we've eliminated two of the choices. And hopefully these aren't the same like last time. There's a good, let's see. So there's an and, there's an and, there's an and. Okay. So again, they're somehow they have two choices the same. I'm going to modify choice C. Let's say that we do have to go to school. All right. So which one is it? All right. So let's double check. R, where was R? So R's we go sledding. So we go sledding, we go sledding. So that's R, both of them. P is there is a blizzard. So there is a blizzard, there is a blizzard. And then Q is we do not have to go to school. Well, Q, so that means do not have to go to school, where this one is do. So this is what we want. That right there is not Q, because we do have to go to school. Do not is Q, do go is not Q. All right. So A is the answer. So again, this is something that, like I said, it takes practice. The messier it gets, first of all, just break it down piece by piece. Okay, and so that's why the first thing I look for is the if and only if. A double arrow goes both ways, and so just by identifying that instead of just an if then, that makes it a little bit more straightforward. Then I look for and, both our choices have and, and then basically look to see what they have different, and then look at the R's, the phrases themselves or the statements. All right, just like a big word operations problem, break it down into smaller chunks. Okay. So that was multiple choice. Let's see, why are these not multiple choice? Well, because we're writing a compound statement in symbolic form. So now they're giving us the English. Now we have to put it into symbol form. Okay. So let's start with this. 14, if I like a song or the DJ is entertaining, then I do not change the station. Okay. All right. What else? Oh, let the letters assigned to the simple statements represent English sentences that are not negated. Okay. It's important to read instructions. So when we have like a song, DJ is entertaining, and then do not change the station. So we need a P, we need a Q, and we need an R. Okay. The P is I like the song. We'll abbreviate these. Q is DJ is entertaining. And then R, now don't say I do not change the station because it says are not negated. So we can't put the not there. So R is I do change the station. All right, so what's left over? Well, we have an if-then statement and look for your connective. So notice that I'm underlining the statements. So if you underline the statements, then what's left over is the connectives. So I've got an if-then as well as an or. Okay. So going back to this, so which one is the higher priority? The conditional is a higher priority than the or. So we need an if then, so do your arrow. And since that's the higher priority than the or, the parentheses around everything in front and after the if then. We may not meet these, but let's see. All right, so if I like the song or the DJ is entertaining, then so what that tells me. So everything between the if then, that's in parentheses. So if I like the song or the DJ is entertaining, how do I write that? Okay. Well, I like the song is P, or downward arrow. The DJ is entertaining, well, that's Q. So we know that's all in parentheses because that's between the if then. So we need parentheses around all of it. Then, so after the arrow, I do not change the station. Well, because they said we can't negate our basic statement, R is I do change the station, but I am not changing the station. That is not R. Now, do we really need the parentheses here? No, because there's only one operation. We have to have those parentheses there because they were doing those before, or all together. Then we're going to do the if then. Okay. All right. So let's keep going. I changed the station if and only if it's not true that I like both the song and the DJ's entertaining. Ooh. Right, this sounds like fun. So let's underline our statements. So I changed the station. What do we say? So that is our R. If and only if it's not true that I both like the song, that is a P, and the DJ is entertaining, so that is Q. So what are our connectives? We have an if and only if. Not true. Now, not true is not a connective, but it is a negation. That both is important. I like the song and the DJ is entertaining. All right. So the if and only if says you have a double arrow. Okay. Now, naturally, the biconditional, the if and only if is a high priority. So I'm going to go ahead and put parentheses just because, because there's no higher order unless we'll see what the rest of the sentence is. And so both I like the song and the DJ is entertaining. Okay. So that both tells me that those are connected. They need to be inside of parentheses. Okay. And it's after the if and only if, so it's going to be on the right hand side. I like the song, which is P. And the DJ is entertaining. So and Q. Now, so I've taken care of all that. But what about the not true part? Okay. The if and only if, so it's still after the if and only if. How do I do not true? That's not, didn't leave enough room here. So it's not true that both P and Q. So that not true becomes the negation. Okay. But all of this, if you notice, after the if and only if, it's not true that both I like the song and the DJ is entertaining. Okay. So all of that has to come after or to the right of the double arrow. Okay. And the reason that the P and Q is in parentheses because it's both I like the song and the G is entertaining. Okay. So that's why the negation is outside the parentheses. Okay. Now, what's before the if and only if? I change the station, and that's it. I change the station is R. All right. So basically, you never had to do this with order of operations. You didn't have to have somebody write out all the steps in English and then translate them into math for order of operations. That's what we're doing here, right? We're taking these very basic ideas of and or and if then and translating them, making sentences and translating them. But I can't emphasize enough is, just for these tips here, let me write them out. So one is underline your statements. Okay. Two is define your statements. So, and I'll say in a positive way. All right, so when I say define your statements, that's what I'm talking about over here. P equals, Q equals, R equals. And it's good habit to not use, to not have your statements have a not in them, because that gets it gets confusing if you start with nots. Right. It's much easier to negate a positive statement than I think it is to negate a negative statement or deal with negative statements. So the logic just flows a little bit better if you start with positive statements without your nots. And then three, identify connectives. So that's why I was circling when I say identify, I was circling my if and only if, the both and the not true. Now remember, not true, that's a negation. So technically it's not a connective, but I'm going to include that because that's going to be part of our symbols. Like up here, it was an if then and an or. Okay. So identify your connectives. And then 4, determine dominance. So I'm going to use their language. Or determine priority if we were talking about order of operations. Yeah. That tells you, like when you have lots of stuff going on, that tells you where your parentheses are, because in this case, the biconditional is the most dominant. So everything on each side is really is like its own little step. And again, once you identify like the main one, that main one is going to be what divides your sentence into parts. So since that was the main connective, everything before that connective is the left side of my symbols. Everything after the connective is the right side. All right, let's do one more, and then I think we'll call it good. Yeah. At least I get to call it good. You get to go and do your homework. Okay, so we're still dealing with the same, we're looking at 16. So we're still dealing with the same, P's, Q's, and R's. So if I like the song, do not change the station if and only if the DJ is entertaining. Okay, so we have all 3 of our statements in there. So what are our connectives? If and only if. And then I do not. And then, okay. So there's an if. So there's an if and only if, and then there's ifs outside of that. Okay, so this one's going to get messy. But which one is the most important? Biconditionals are always the most important over conditions, over anything. Okay, you print, parentheses before and after the if and only if. Okay, so let's start with after, because that's the shorter one. So after the if and only if, we have if the DJ is entertaining. DJ entertaining is Q. And before the if and only if I like a song, I do not change station. So this is an if, and then is implied. Okay, so if I like the song, then I do not change the station. So all of that is before the if and only if. And so this is, what is I like the song? I like the song is P. I do not change, so that's P. I do not change the station. That would be not R. So how do you do if P, then not R? Well, the if is the arrow, and then if P, then not R. Okay. So the translations, if you just have 2 statements, your translations are relatively straightforward. Once you start getting those or more, that's when the translations can get messy. And that's when you really, I think these steps are really important. And, again, to me, this is like showing your work on a test. Right? Because if you're doing this, I know that you're trying to actually break down the problem piece by piece by piece. Right? This is sort of like when we had those large order of operation problems. Theoretically, you could just plug it in your calculator all at once and have no clue what you're doing and possibly get a right answer if you put the calculator correct. Well, there is no calculator. I mean, I guess, yes, you could do this in AI and they have no clue what you're doing and might be okay in your homework and then the quizzes and you're going to bomb the test. So there is no single calculators on this if you want to pass this test, because you got to know how to do this. All right. So identify what your statements are. What's left over is going to be your connectives. Then you got to figure out what order to put those connectives in, and then just build from there. All right. The only way that you can get decent at this is practice. There's no way around it. Yeah. And so, and that's what the homework is for. All right. Well, that's all I have, at least for this. And so the next video is we're going to start talking about truth tables. And so just like with Venn diagrams, we had to learn to read Venn diagrams. And then once we did that, then we did the operations. And so once we get into 3.3, we're going to talk about how to set up truth tables. And then we're going to work up to like, how do we put something like this in a truth table? Okay. And again, these are like higher order problems. We're going to start small and work our way up. But that will be 3.3, and that will be after full break. Okay. Which that's so if you have any questions, email me. Otherwise, have a good day. And I'll see you soon.